Hello friends, welcome back to channel Civil Engineering Academy. Today we will break down the essential building materials, that is cement, sand, aggregates and water, and understand their role in construction. So let's get started. Introduction to concrete as a construction material. Content of this video are basically cement, aggregate and water and admixtures. Concrete and its constituents: cement, coarse aggregate, fine aggregate that is sand, water and admixtures. Cement. It is a mixture of limestone and clay heated in kiln to 1400 to 1600 degrees Celsius. It is manufactured by mixing calcareous and argillaceous material, burning and the grinding it to form the cement. No matter shall be added after burning other than gypsum. Aggregates. Aggregates are of two types, coarse aggregates and fine aggregates. The next ingredient is water. Water used for mixing and curing shall be clean, free from the injurious materials such as oil, alkalis, salts, sugars and other organic materials that may be harmful to concrete and steel. Next, an optional ingredient of the concrete is nothing but the admixtures. Admixtures is used to modify the properties of ordinary concrete so as to make it suitable for any condition. Broadly classified as chemical admixtures and mineral admixtures. Hydration of cement. When Portland cement is mixed with water, its chemical compound constituents undergo a series of reactions that causes it to harden. This chemical reaction is called as a hydration. Hydration starts as soon as water and the cement are mixed. The reaction liberates the amount of heat and this heat is called as a heat of hydration. Alkalis of cement and their effect. Tricalcium silicate, that is C3S. It hardens rapidly and is largely responsible for initial setting time of cement and also responsible for early strength. Early strength of Portland cement concrete is higher with increased percentage of tricalcium silicate. Dicalcium silicate, that is C2S. It hardens slowly and contributes largely to strength increases at ages beyond 7 days. Tricalcium aluminate, that is C3A. It liberates a high amount of heat during the first few days of hardening and contributes in the early strength of concrete. Tetracalcium aluminoferrite, that is C4AF. It contributes slight to gain of strength, mainly contribute in making cement look grey. Now next is classification of cement. Cement is broadly classified into 4 types, that is natural cement, pozzolana cement, slag cement and Portland cement. Natural cement. Natural cement is obtained by burning and crushing of 20 to 40% clay, carbonate of lime and small amount of magnesium carbonate. It is brown in color. It resembles very costly element, hydraulic lime, and sets very quickly and is very strong as compared to the artificial cement. Pozzolana cement. Pozzolana is the material which is found in the deposits of volcanic ash, or it can be said that it is a volcanic ash of which simple grinding gives cement. Pozzolana or volcanic ash after grinding when mixed with the lime without heating gives hydraulic cement. Hydraulic cement, a cement that not only hardens with reaction with water but also forms a water resistant product. Advantages of pozzolana cement: it evolves less heat during setting. It possesses higher tensile strength. It imparts higher degree of water tightness. It attains compressive strength with age. It can resist action of sulfate. It imparts plasticity and the workability to mortar and the concrete prepared from it. It offers great resistance to expansion. Slag cement. It is made up of mixing blast furnace slag which contains silicates of calcium and aluminium with hydrated lime. The other ingredients which are added are clay, salts or caustic soda. Portland cement. It is refined powder of calcined product of clay and limestone. It is having controlled composition and hence have controlled setting time. Other types of cement are acid resistant cement, blast furnace cement, colored cement, white cement, rapid hardening cement, high alumina cement, expanding cement, low heat cement, quick setting cement, and sulfate resisting cement. Now, one by one, we will take details of each type of cement. First one, acid resistant cement. It is composed of acid resisting aggregates like quartz, additives such as a sodium fluorosilicate, an aqueous solution of sodium silicate or sodium glass. Sodium fluorosilicate accelerates the hardening process of soluble glass and hence increases the resistance to acid. Since this cement is poorly resistant to water, 0.5% linseed oil or 2% ceramide is added to increase its water resistance. Blast furnace cement. This cement is prepared from the slag of blast furnace. This slag contains basic element of cement, that is alumina, lime and silica. Clinkers of cements are the grinded with 60 to 65% of slag. The properties are same except less strength gaining in the early period with increased curing periods. Colored cement. It is obtained by mixing mineral pigment with ordinary cement in the ratio of 5 to 10%. If percentage is increased above it, it may affect the strength of cement. Chromium oxide gives green color, white cobalt imparts blue color, iron oxide in the different proportions give brown, red or yellow color. This type of cement is generally used in ornamental work of structure. White cement. This cement is also an ordinary cement which is prepared from the colorless oxides of iron, manganese or chromium. For burning of this cement, oil is used instead of coal. It should be carefully transported and stored in a closed containers only. It is used for floor finish, plaster work and ornamental work. Rapid hardening cement. This cement is slightly costlier than ordinary cement. Its initial and final setting time is same. The only change is that it attains high strength in early days due to the following facts. Very fine grinding, burning at high temperature, increased lime content in cement composition. Advantages of rapid hardening cement. As it sets rapidly, construction work may be carried out speedily. Increase the frequency of use of formwork due to possible early removal. Requires short period of curing. Structural members may be loaded early. Result in economical design. High alumina cement. It is produced by grinding clinkers of ore of aluminum and lime. It is specified that total alumina content should not be less than 32% and the ratio by weight of alumina to lime should be between 0.85 to 1.30. Advantages of high alumina cement. It can withstand high temperature. Initial setting time is more than 3 hours and final setting time is 5 hours. Hence, it allows more time for mixing and placing operation. Evolves great heat during setting and hence not affected by frost. Resists the action of acid in better way. Expanding cement. It is produced by adding an expanding medium like sulfoaluminate. Hence, this cement expands while others shrink. It is used for construction of water retaining structures and for repairing the damaged concrete surfaces. Low heat cement. Considerable heat is produced during the setting action of cement, and to overcome this problem, percentage of tricalcium aluminate, that is C3A, is lower down and the percentage of dicalcium silicate, that is C2S, is increased. It possesses less compressive strength and its initial setting time is 1 hour and final setting time is 10 hours. Setting cement. It is produced by adding slight amount of aluminum sulfates, which is good accelerator, and by finally grinding the cement. Percentage of gypsum and other retardants are also greatly decreased. The setting action starts within 5 minutes and it becomes hard like a stone in 30 minutes. Cement is used in underwater construction in large extent. Sulfate resisting cement. In this cement, the percentage of tricalcium aluminate is kept below 5 to 6%. Which increases resisting power against the sulfates. This cement is used for structures which are likely to be damaged by the severe alkaline conditions such as a canal lining, culverts, siphon, etc. Testing of cement. It can be categorized in two categories, that is field testing and laboratory testing. Field testing. After opening cement bag, the color of cement should be greenish grey with no lumps. After taking pinch of cement, it should give smooth filling. After inserting hand in cement bag, it should give cool filling. Take a handful of cement and throw it in bucket of water. The particles should flow for some time before they sink. And the next is laboratory testing. Laboratory testing has to be done to determine the properties of cement. Major tests to be performed are fineness test, soundness test, consistency test, initial and final setting time. Aggregates. The aggregates can be broadly classified into two categories, that is coarse aggregate and fine aggregate. Mainly sand or aggregate having the size less than 4.75 mm is called as a fine aggregate. Importance of aggregate. It reduces the cost of concrete to 1/4 to 1/8 of total cost. It reduces the thermal cracking. It reduces shrinkage. Impart unit weight to concrete. Effects of aggregate on concrete. Shape and texture of aggregate affects the workability of concrete. Sufficient paste is required to coat the aggregate and to provide lubrication to decrease the interaction between aggregate at the time of mixing. The ideal is one which is close to spherical in shape with relative smooth surface. Flat or elongated aggregate should be avoided. More angular shape, rough surface will decrease the workability of the concrete and hence require more paste. Rough surface requires more lubrication for movement. Rough surface improves the mechanical bonding between aggregates. Shape can influence by increasing surface area available for bonding between the paste. Classification of aggregate based on size. Fine aggregate and coarse aggregate. Based on specific gravity. Lightweight, normal weight and heavy weight. Next is natural gravel and crushed aggregates. Depends on shape, round, cubical, angular, elongated and flaky. Based on texture, smooth, granular, crystalline, honeycomb and porous. Then next is fine aggregate and another is coarse aggregates. Effect of shape of aggregate on concrete. Rounded aggregate gives good workability, low water demand but poor in bond. Irregular, it gives fair workability and low water demand. Angular aggregate increases water demand but gives good bond. Elongated aggregate may lack cohesion and increases fineness. Flaky aggregate sacks gives workability problem. Testing of aggregate. Determination of flakiness index, determination of elongation index, determination of clay, fine silt and fine sand, determination of organic impurities, determination of specific gravity and water absorption, determination of bulk density. Mechanical properties of aggregate, aggregate crushing value, aggregate impact value and aggregate abrasion value. Next ingredient is water. Quality of water. Water is an important ingredient of concrete as it actively participates in the chemical reaction with cement. If water is suitable for drinking, then it is suitable for making concrete. Water should be free from organic matter and pH of water should lie between 6 to 8. There should be lower concentration of carbonates and bicarbonate of sodium and potassium as it considerably affects the setting time of cement and strength of concrete. Silt and suspended particles are undesirable as they interfere with the setting, hardening and bond characteristics. Water should be free from the salts of manganese, tin, zinc, copper and lead since it is proved that it causes a marked reduction in strength of concrete. Water requirement in concrete. As a component of paste, about 20% of water by weight is needed to hydrate all the cement. 15 to 20% more to provide space for cement hydration products, and then usually more water is needed to make makes workable. At about 65 to 70% water concentration, permeability of concrete increases greatly, so it is suggested to limit water 60%. It is found that water concentration above 40% leads to micro hole as uncombined water evaporates and the strength drops progressively. Admixtures. Admixtures are nothing but the chemical compound in concrete other than the hydraulic cement, water and aggregate. Mineral additives which are added to concrete before or during mixing to modify one or more specific properties of concrete in the fresh or hardened stage. Function of admixtures: to accelerate the initial setting and to speed up the rate of development of strength at early stage, to retard the initial set and to keep concrete workable for longer time for placement, to enhance the workability, to improve the pumpability and the flowability, to reduce the segregation in grout and concrete mixtures, to increase the strength of concrete by reducing the water content and by densification of concrete, to increase the durability of concrete, to inhibit the corrosion of reinforcement in concrete, to increase the resistance to chemical attack, to reduce the heat of hydration, to increase the bond between old and new surfaces, to enhance the bond of concrete to the steel reinforcement. Thank you so much for watching video. If you like the content of this video, please share it with your friends and subscribe the channel.